We have a couple ways that we're actually going to classify quantitative data. So that's our numerical data. But one of the first ways we're going to classify it is being whether it is discrete or continuous. So quantitative variables, we divide them into discrete and continuous. And like I said, there's something else we can divide them into. So discrete, it means that the possible values that it could be can be listed. Essentially, like you can count them out. So usually that's going to be things like number of marriages, your family size, if you counted your age in just years simply and not, like portions of a year. So usually this is stuff that it's like can be counted. So what it means to be discrete is essentially that one of the kind of quick ways to think about it is it's like something that can be represented as whole numbers or as integers. Is usually one way you can think about it. So it's a little more complex than that, but that's kind of you get stuck and you're trying to quickly figure it out. Something can be counted or it can be represented with the integers. Continuous, the possible values can be any value in some interval. So this can be something like weight, your height. If you're in a race, like how long does it take you to finish the race? Things that are timed like that. So in this case, this is things that usually you can't necessarily count. So this is stuff that's usually like measurements. Like I said, your weight or your height or your time in seconds, things like that. So measurements, and this is usually something that's it's in the real numbers or your rational numbers. So what it really comes down to is that when we talk about something being discrete, there is a possible list of values that can be, and those values have the same spacing between them. So, like I said, usually integers is a good example for that. So if you're talking about your family size, like I have 3 people in my family, or I can have 4 people in my family, or I can have 5 people in my family, but I can't have 3.5 people in my family. So when we're talking about discrete and being something that's counted, that's what I mean. It's like things that you can't represent necessarily with decimals and fractions. Like I said, it's not completely what a discrete variable is, but it's a good way to think about it. Um, things like weight, you can have 2 people who say they might say they weigh the same weight, but there's going to be a slight microscopic difference, like really, really small difference in between them, because weight is basically it's on a spectrum. So somebody can weigh, 150 pounds, but they can also weigh 150.1 pounds or 150.11 pounds or 150.111 pounds. There is like this range of values that you can have. Got to clear my page. So just kind of quickly, this is starting with a mathematical definition, a little closer. It's not perfect for a discrete variable or discrete number. So discrete numbers come from a finite or countably infinite set, such as your integers. A set of numbers is discrete if when we order it, so we order it from like smallest to largest, there cannot be another number between 2 consecutive numbers in the set. So like with the integers or something like that. So this is not necessarily just integers, this is natural numbers. But something that you're counting, like I said, like number of people in your family. Sorry, I didn't mean to do those two. 2 consecutive numbers like 2 and 3, what we see is we don't have another integer in there. There's nothing here. So there's not another integer I can fit between those 2 numbers. So that's what we kind of mean by discrete, is that I can list my numbers and I can't find, and if I have 2 of them and they're next to each other, there shouldn't be another number in between them that I can find. So a discrete data set represents exact values that you can count, such as like things like numbers of people in a classroom. Continuous comes from infinite sets that represent a range of values. So they're not countable. Well, not necessarily, that could be part of it, but I wouldn't think about the countability part of this. But like I said, they're numbers that it could be represented as a range of values in which the distance between each value is infinitesimally small. So when you're talking about like the difference between integers, so you go from 2 to 3, the difference between those is 1. If you go to 3 to 4, the difference is 1. That keeps that distance like that. But when you're talking about continuous numbers, the distance can be infinitesimally small because you can have 1 and you can have 1.01 or 1.001 or 1.0001, and those zeros keep going to infinity, and what you get is the difference between 1 and its next number is almost non-existent. It's infinitesimally small. So a set of numbers is continuous if there's will always be a number from the set in between any two numbers in the set. So it doesn't matter what I pick. If we're talking about, let's say, the real numbers, I'd pick 2 and 3, and in the real numbers, there is another number that fits in between those, 2.5. And then there's still a number that fits in between 2 and 2.5, 2.25. And then there's another number that fits in here between 2 and 2.5, 2.2. And there's another number that fits between 2 and 2.2. There's 2.1. And you could just keep on going with this. You can always find another number that's going to fit in between one number and the next in the set of real numbers. That's kind of what we mean by continuous. So continuous means that when you look at that spectrum of numbers, there's infinite amount of possibilities in there for a value to obtain. So we want to decide which of the following are discrete and which are continuous. So sometimes it's a little ambiguous, like things like age. So that's why we're trying to specify the age of a person at their last birthday. So when they hit that birthday, what was their age? Is that discrete or continuous? The height of a person. Can you measure a height of a person, with a countable number of possibilities, or is it a spectrum? So is it continuous? Number of siblings a person has, the distance a person commutes to work, a person's body temperature. Okay, so give you a second to think about that. Okay. So if you talk about the age of a person, their last birthday, so, like they're 27 when they hit that birthday, so their 27th birthday, right? You don't have a 27.5th birthday or 27.52 birthday, something like that. It is just 27. And then your next birthday is 28. You don't have birthdays in between. If you're talking about age of a person, their last birthday, that would be discrete. The height of a person, that's continuous, because you could be 5 feet 3 inches, or you could be 5 feet 3.2 inches, or 5 foot 0.1 inches. You have a spectrum of values you can be there. Number of siblings a person can have. Well, hopefully that's discrete. I'm going to say that's discrete because you usually count your siblings as in I have, say, count your half siblings a half person. Your sibling is a full person. So if you have 3 siblings, doesn't matter if they're full siblings, half siblings, step siblings, you have 3 siblings. There's something you can count. The distance a person commutes to work. Well, once again, you could drive, 43 miles to work, or 43 and a half miles of work, or 43 and a quarter miles of work, or an 1/8 or a 16th, blah, blah, blah. So that would be continuous. Now, a person's body temperature technically would be continuous. Just want to point out that this is a little bit dependent on the device of measurement. So if you used a mercury thermometer, then you would say it's continuous, because with a mercury thermometer, the temperature could be here, but it can keep on going up and it fills in that entire space. Everything in there it could possibly be. However, sometimes you might consider it discrete if you use a digital thermometer. Because with a digital thermometer, usually it only goes out to 1 decimal place. So you can have a temperature of 98.2 or 98.3. There's not anything in between those two numbers. So This it can be a little ambiguous as far as we're concerned. I would say body temperature would be a continuous measurement, but that's just something to bear in mind. If you end up doing more statistics, the way you might treat those numbers might be a little different based on the kind of device you're using to measure. And then the other part of this, so this is just another objective, we'll put it here because this is still to do with your quantitative measurements. So not only can they be discrete or continuous, but they could also be considered a ratio or an interval measurement. So this is part of that. Part of this, what we consider our levels of measurement. So quantitative variables can be categorized as having a ratio or interval level of measurement. The ratio measurement, this means that zero means that we have an absence of a quantity, and our ratios have a meaning to them. So an example would be like height. If you have a height, if something has a height of 0, then it has no height. It basically doesn't exist. If your number of pets is 0, then you have 0 pets. So things that have natural zeros would be considered a ratio measurement. So for the most part, you're going to have ratio measurements. Interval measurements are usually based on the kind of measurement scales that you are using. So with an interval level of measurement, 0 does not mean the absence of the quantity, and ratios do not have meaning. So what we're talking about here is when we're talking about ratios having meaning, something can have a height of 10 inches and something can have a height of 5 inches. So that's a ratio of 1 to 2. That ratio has meaning, something doubled. This doesn't quite work when you're talking about interval measurement. So the big difference with interval measurement is this absence of 0 having a natural meaning to it. So examples of this would be like time on a clock. So we say time begins, or our clock, our day begins at midnight. So that's one of the things. So it's like we begin at midnight, and if you did this in military time, this is 100 hours. But that 0, saying that 100 hours, does not mean that time ceased to exist. It's an arbitrary measurement of when we say the day is going to begin. We just decided that at a certain time that we mark as being 100 hours or midnight is going to be the beginning of the new day. So it's an arbitrary measurement when the time on the clock is 000. It doesn't mean time ceased to exist. It's just an arbitrary measurement. And we know that if it's like 12 a.m. or 12 p.m., whatever, and 6 p.m., that doesn't mean, you still get a ratio of a half. But what does that ratio mean? If a ratio of 2, what does that ratio mean in this case? Like here, it makes sense if something had a height of 5 centimeters and then it had 10 centimeters, you have this ratio where it doubled. Well, we're not saying time doubled here. We're just saying we've got a ratio 2, but what is the meaning of that? So that's what I mean that ratio doesn't have a meaning. Another example of this would be ACT scores. ACT scores. It's also ACT scores, but SAT scores. So sometimes we have things that we measure that are quantitative measurements, but they actually don't even have a 0. So we have time, which time can have a 0, but doesn't mean the lack of existence of time. Or you can have something like SAT scores where zeros just don't exist. You cannot get a score of a 0. I think the lowest score you can get is 400. So our examples here would be, see if it's ratio or interval. Number of siblings a person has. Now you have to figure out, do we have a natural 0 to it? Or a meaningful 0? So ratio would have that natural 0. Interval does not. So just having 0 siblings, or no, it was a count of 0 siblings, does that actually mean 0? If you measure temperature in Celsius, when you have a temperature of Celsius, is that a ratio or an interval measurement? Does 0 degrees Celsius mean that we no longer have temperature? The price of shoes. If shoes are $0, does that mean that we don't have a price? So it's like I said, I'm trying to think if that 0 makes sense to you. So number of siblings, this would clearly be ratio, because if I have 0 sibling, or a count of 0 for siblings, that means I just have 0 siblings. And the ratios would make sense as well. If somebody has 2 siblings and somebody has, 4 siblings, somebody has double the siblings. So we have ratios that make sense. The temperature outdoors. So if we measure it in Celsius, 0 degrees Celsius is when water freezes. That is where that measurement came from. So the Celsius scale, the 0 is arbitrary. We just based it off something happened, water freezes. That's the only reason we picked it. This one is an interval, because when the temperature is 0, we don't have no temperature anymore, because the temperature can be less than 0. It can go down further. Also, the ratios don't make sense. It's trying to think a good way to put it. We don't usually say the heat doubled necessarily when we're talking about temperatures. Because if you think of this even like in Fahrenheit, like if it's 20 degrees Fahrenheit and then it's 40 degrees Fahrenheit, temperature doesn't necessarily double. Just the ratios of that doesn't make sense. Price of shoes, I would argue this is a ratio. Because once again, if the price of shoes is 0, then there's no price for those shoes. Year to the next presidential election. Oh, year of the next presidential election in years until the next presidential election. So these are a little tricky here. So the next presidential election, let me see, what was that, 24? So our next one is going to be this year, 2028 will be the next presidential election. So if I'm measuring time in years, what was year 0? Is that where time ceased to exist? So when we measure time in years, it's another one of those arbitrary measurements, because year 0 is just supposed to mark for starting, I was going to say this wrong. It's supposed to represent the year that Jesus Christ was born. So once again, it's an arbitrary measurement. Time existed before time 0. Time exists after time 0. So it's not a measurement that makes sense, or a 0 that makes sense. But if you talk about years until the next presidential election, there's going to be 4 years. And then eventually it's going to be 3 years. And then it'll be 2. And then it'll be 1. And then there's going to be 0 years to the next presidential election. So that makes sense, because it's counting how many years. And at that point, I don't have any more years to go when I hit year 0. So in this case, this 0 means no more years. We have hit the end of our this schedule that we're looking at. So sometimes something like time, depending how you're talking about it, could be a ratio, could be an interval. When you're talking about like your time as in years, is an interval. When you're talking about how long in years it takes for something to happen, that's a ratio.